Following on from our previous video, we are firing a cannonball out at 50 meters per second, we're on Earth. So no matter where the cannonball is, gravity is always acting on it. Meaning that because gravity is 10 meters per second squared, it means that it would decrease the cannonball's speed by 10 every second. So when we fire the cannonball out at 50 meters per second, well, it will travel really fast at first, but then as time goes on, the velocity starts to decrease, and there will come a point when the velocity is zero, and then it starts to free fall back down to Earth. Okay. Now, my question for this video is, how do you calculate the maximum height? All that you're given is that we're on Earth, and this is 50 it's being fired out at 50 meters per second. So in order to find out the maximum height, draw your velocity time graph. And remember, in the past we used speed time graph, but I'm asking you to abandon the speed time graph and start to adopt the velocity time graph. Because velocity is so much more useful than the speed time graph. I can't explain why now, but it is so much better. So start to use velocity instead of speed. Velocity is so much better. Okay, so remember, we are firing it out at 50 meters per second, meaning that when time equals 0, the speed is 50. Now, because gravity is always acting downwards, it would decrease the speed by 10 every second. So 1 second later, the speed would be 40. That's why it's here. And then another second later, it would decrease by another 10, and so on. And this is the maximum. Time equals 5 here is when the velocity of the cannonball is 0. So 0 here. Now we remember that. Remember our three graphs. Here you've got acceleration, time, and in the past I asked you to use speed, time, but don't use speed anymore. Use velocities. It's so much better. And then you've got your distance, time. Soon I will ask you to abandon distance and use something else. But for the time being, you know, with velocity time graph, the area underneath the graph represents the distance traveled. Well, hang on, let me clear this up. Well, if you know that this point here is when the cannonball reaches its maximum height, when the cannonball reaches its maximum height, the velocity will be 0 at this point here. So you know, well, if you calculate the area here, that would represent the distance traveled by the cannonball. Okay. Well, we don't care about the time going down. Because we just want to find out the maximum height. We only care about the area here. The area of the area underneath the velocity time graph represents a distance traveled. Okay. Well, for the time being, it represents a distance traveled. So if you want to know the maximum height here, work out the area underneath this graph. So this one here, the height here would be 50. 50 times 5 here, and times 5, and then we divide it by 2 because it's half of a rectangle. So this here would be I'm just going to this would be 250, okay, divided by 2, and that equals 125 meters. So back to this thing here. The just by knowing the initial speed and us being on Earth, by knowing the gravity, we know that the maximum height that the cannonball will reach will be 125 meters. And you can adopt this technique for the moon if you like. You could fire a cannonball on a moon And well, all you need to know is that G equals 1.2, 1.622, I think, 1.622. And then if, let's say we fire it at 50 meters per second, you can actually calculate the maximum height of this cannonball on the moon. So I will set that as an exercise for you in the next video. Okay.